Hello everyone, welcome back to Bytes of CSE, and in this video we'll learn 3 important reasons why sigmoid activation function is no longer used in complex neural networks. So sigmoid activation function takes in a continuous real value and transforms that value within a range of 0 and 1 using this equation. So when the value of your x is very large, the sigmoid value will be closer to 1, and if the value of x is small, the sigmoid value will tend towards 0. And this is done to ensure that the input to the next layer in the neural network stays in a fixed range and the weights also stay stable. But yet we are not using sigmoid function much nowadays. So the first reason is the output of the sigmoid function is not zero-centered. Now, what is a zero-centered output with respect to an activation function in a neural network? It means that the output has a mean value of approximately 0. Now, this is very crucial for efficient training in neural network, especially if we are using some gradient-based optimization algorithm like stochastic gradient descent. So a zero-centered output ensures that the gradients point in a balanced direction, which allows the model to explore the loss landscape more effectively. It contributes to smoother and more stable updates to models' weights, which leads to faster convergence and better generalization. And ultimately, it helps the network to learn faster and more effectively. Now, if the outputs are not zero-centered, if they are consistently positive or negative, then the gradients might tend to push the value, push the weights of the weight factors in a specific direction, which potentially slows down the convergence or even lead to some unstable training. The second point is high computational complexity. The exponential function, that is e to the power x, e to the power minus x, this involves hundreds of addition, subtraction, multiplication, division on a general purpose CPU, and this computation is very inefficient. The third problem is the saturation problem. If you look at the sigmoid curve, the right and the left hand part of the curve is nearly flat, and when the input value of x is very large, or if it is a very small negative number, in both the cases the gradient of the sigmoid function will approach 0, and this will lead to a slowing down of the parameter update. This phenomena is also known as the sigmoid saturation problem. Another thing is the derivative of a sigmoid function stays within a range of 0 and 0.25, so 0 in open interval and 0.25 in closed interval. So suppose if your neural network is complex, it involves many layers, then the partial derivative calculated according to the chain rule would imply multiplication of many numbers which is less than 0.25, and generally the absolute value of the initialized weights are generally less than 1, and this will mean that the gradients will approach 0, and this will ultimately lead to the vanishing gradient problem. So these are the 3 reasons why sigmoid activation functions are not used much these days. So I hope it helped. Thank you for watching.